Hi, this is Paul Steen with the Volunteer Stream Monitoring Program of MiCorps, here to show you how to use a new tool that we've developed to help different MiCorps organizations be able to analyze and look at their data in consistent ways with each other across the state. So to get to this tool, you go to our website, micorps.net, and you come to streams, go to stream monitoring, which will bring us to this page. And then once here, go to access stream documents and resources. And then we have two things for you to consider. There's an order level Excel sheet if you do your identifications down to the MiCorps order level, or the family level data sheet. So you pick which one you want to use. They basically work the same, but the level of identification is different, obviously. So for this example today, and I show you how it's going to work, I'm going to use the family level. So I'm going to download that and open it in Excel and be right back after we switch over to that. Okay, we're back. Now we're in the spreadsheet. You'll see that these spreadsheets have 4 tabs at the bottom, and we'll talk about how each of those works in this process of entering and checking your data, your macroinvertebrate data for your stream monitoring. So we'll start with this sample sites tab. This is where you enter the different locations that you go to, your site ID that you eventually will put into the MiCorps database, the name of your creek. We have a few examples here so you can see what I did. The county, latitude, longitude, some comments. So different ways to list out your sites here. The most important thing, I believe, is making sure this MiCorps site ID is accurate so that eventually we'll be able to use this spreadsheet to upload our data directly into the MiCorps online database. So this is what you start with when you set up the spreadsheet. Enter your sites here. Then you go to, on the bottom, family macroinvertebrate sheet. And this is where your data is actually entered in from your MiCorps data sheets. So the lines at the top are pretty much exactly what you will have on a MiCorps datasheet. If I scroll over, this habitat section is what is available on the front side of a MiCorps datasheet. You change these to presence, absence, or not recorded if your volunteers didn't do that part of the datasheet. And then as you scroll over, you will see all of the family level insect identification. So you just enter the number that had been found for each of these different insect families. The number on top, that's the tolerance value that the spreadsheet uses to help you calculate your water quality rating and determine the number of sensitive families that you have. So if I just scroll over, you can see so many options. All the insect families that you may find will be listed here, just like in your data sheet. I'll scroll over faster. Then at this end, are the metrics that are auto-calculated for your data, so you don't have to do this yourself. It has formulas in here that will do this for you. So the main metrics that we think about for the family level are total abundance. We think about total diversity, the number of overall groups in your sample, EPT diversity, ephemera, Plecoptera, Trichoptera, and then your sensitive diversity, which is the number of groups you have that have a tolerance of 3 or less, and then your MiCorps rating, which runs between 0 and 10 and tells you qualitatively good, excellent, fair, very good, that stuff. So this is where you enter your data. If I scroll back to the very beginning, you'll see in column B here, it's a drop down. So you pick which one of your creeks that this sample is for. So you don't have to re-enter that every time. You just pick what creek you're doing, but you do always have to enter this other information by hand. So that's where the raw data goes. Pretty simple, just data entry process there. But then what makes this spreadsheet useful is this tab that will say data summary, either family data summary or ordered data summary, depending on which data sheet you're using. And it looks like this. It's called the visualization tool and outlier check. So what you do is you pick the site you're interested in. You pick the season you're interested in. Typically in MiCorps, we look at spring and fall different because they will hold much different macroinvertebrate communities typically, but there is an option of looking at all the data for this particular site at once. Let's just check out the spring data for now. And you can see that this, as I pick the site and as I pick the season, everything beneath it gets auto-populated. It's pulling directly from your family macroinvertebrates tab, so you don't have to enter any of this in manually. It just, boom, changes it. So if I change it to fall, you'll see how everything, boom, changes to fall. I'll go back to spring. All right, and then here we, just some quick bits of information. When your sampling started, your year of your most recent sampling, and then averages for all of our main metrics that we were just talking about, all the way down at this point to row 100. So it's getting the average. We can see that, the typical results for this particular site. Then on the right-hand side, each of these columns is graphed. So you can then quickly visualize how those change. And of course, the graphs change as you change what view of the data you're looking at. So here we have an abundance graph and the different metrics. This particular site seems to be getting better over time. We're finding more diversity across all of the metrics. And we're also finding just more here in general. So both abundance and diversity are going up. Seems like this creek is getting better. But of course, the big question that we're always wondering about when we look at our data are any of our samples improperly taken? Did a volunteer stray from the sampling procedure, or were the weather conditions such that maybe might make this data unrepresentative of any particular sample, unrepresentative of the normal conditions at this site? So what we do, and what your QAP, your quality assurance plan, will have you do is look at all of this data with a 40% relative difference check. And this is what, in column T, what we have built in, automated to help you do this. So let's say we were interested in looking at our most recent sample here in 2024, where they brought back, your volunteers brought back 217 macroinvertebrates. All right, so this is where you change the year. That shows what you're interested in checking. I'm checking 2024. And then we're doing an outlier check to see if any of these points are distinctly outside of the median, greater than 40% outside of the median. So if our data point is 217 and the median is 102 for our data, if I was within 40%, that means that I would expect the lowest number to go down to about 60, and it might range up to about 140 normally. So this particular group of volunteers came back with 217. So in terms of abundance, this is actually considered an outlier. They brought back quite a bit more than they normally do. But you want to check that. So that might raise concerns. Were they keeping too many? But then you want to look at all your diversity, your total family diversity is within the normal bounds. The EPT diversity is in the normal bounds and is actually down a little bit from more recent samples. Not an outlier though. Your sensitive diversity, not an outlier. Your WQR, well, actually going up a little bit, which means it's getting a little worse in terms of WQR. It's still in the bounds of normal. So all their metrics look fine. So I'm not particularly worried about the volunteers keeping more than normal. It could be the stream is actively getting better, and I can just expect people to come back with more as the stream gets healthier. So all this looks totally normal. This outlier check with a 40% difference, relative difference, that is really just a flag for you to identify possible problematic data points, but it's not a hard decision maker. Like it's you, the manager, who's going to decide what is a good sample and what isn't based on all this data. And my conclusion for this particular sample point is it's fine. I'm not too worried about it. Okay, so let's see another example in which it doesn't work out fine, and that's in example 2. So I go over here, change my site, and I'm calling this is what's called flooded river. So in the spring, this particular river does have a tendency to flood, and that can produce bad results if the volunteers are out there sampling and they're sampling in a flooded river, or maybe they're not able to do their proper methodology, right? But if you're not there with them, you might not know what they're doing. But the data can help you get to that. So in this particular case, it looks like in 2021 they went out and they only brought back 58 insects. So let's do a check of 2021. All right. So they came back with 58. The median would be 123. So we are below the median by probably about 60%, which makes this point an outlier. And then you can see some of the other graphs. Total families are way down, where the median is 22 and they only came back with 8 families. EPT, the median is 10 and they came back with 2. The median of sensitive families is 6 and they came back with 0. And then we have a big spike in the WQR rating too. So because every single one of these metrics is saying it's an outlier, like that's an even bigger flag than last time. Now I'm more suspicious. So I might go back to the data sheet, read the comments, try to understand what the volunteers did here. The data sheet may say it or may not, but it might be the case that they couldn't even really get in the river and they were just kind of sampling, reaching their net into the bank, doing improper samples. You can find the volunteer who did this and just ask them directly. If you don't notice this for a couple of years, though, that person probably doesn't remember. So you have to make your decision based on the data and what's on the data sheet if you're looking at doing these checks on old data like we are for this one right here. In this case, I am going to decide I want to cut this data point from my data record. I feel like it was probably collected improperly in a flooded situation. So to cut a data point, you need to go back to your raw data and find that data point in here. I know it's spring 2021 for the flooded river. So this one right here. So what I'm going to do is actually cut this. And now we're going to use our fourth worksheet down here on the bottom. And I'm going to paste that in here. Control V, paste. Okay, so now that data point has been taken out of the main data record, and I put it in this outlier data sheet. And you want to put in the reason for rejection. Notice this column A, this always existed. I just hid it on this sheet. But when you move this over, you now have the ability to type in something there. So you got to give a reason for why you took this out of your data record. And I would say something like all metrics are outside 40% of median. This was a flooded site during sampling. All right. So now you remember when you look back at a later point why you decided to get rid of that particular data point. Not representative of normal conditions at this location. But you're not fully deleting the data. So it's not that you're getting rid of it and you're trying to ignore this didn't happen, but it's what you want your mainline data to do to represent normal everyday conditions that happen at a particular location. And your outlier database is good for understanding what happens when things go kind of out of whack at this site. All right, now if you look back here, that data point is gone from all the graphs. So, okay, last example. Example 3, this one's called new site. And we have only been to this site 5 times in the spring. And let's see, we went only 4 times in the fall. So just not a lot of data available at this site. And so how do you make decisions then when you're just operating off of such little data? Well, you can't really is the answer. Let's just look at 4 data points for the fall samples here. And I want to check, I'll check 2021 probably. Yeah, let's look for 2021. The median is 65 abundance, and they came back this time with 103. Their total family diversity was up, and it is an outlier. EPT is steady. Sensitive families, normally at 0, and they found 1. Notice that does mark it as an outlier. When you're dealing with numbers this small, even just changing from 0 to 1 will make things an outlier. That doesn't mean you reject the data. It's just like some more of an artifact of the math. So you have to be careful that when it says yes, it's an outlier, it doesn't mean you automatically cut it. You have to think about the reasoning here. WQR rating is about the same. So in this case, what do? You do nothing. You have to collect more data on this site before you can make decisions about it. It may be that after you get a few more data points, actually MiCorps asks you to collect 6 data points per season before you're really making these hard decisions, just so you have a better understanding of what's going on. So once I had 2 more samples, maybe I can make some decisions about this particular location. But it may be that finding 103 is entirely normal, and actually finding 100 is absolutely within normal expectations of the MiCorps protocol. So chances are there's nothing wrong with this data point at all, and that'll become more clear as I collect more data. So don't do anything until you at least have 6 points. And even when you only have 6, or let's say even less than 10, you should be pretty stingy with your decisions. When in doubt, keep it in the data record. It will help your decisions into the future. So that's kind of how you use this data sheet. The hope is that all the MiCorps groups out there will put their data record in this sheet, and in the future we'll be able to upload this directly to the MiCorps database. Though that feature is not available yet, you can still get it in here, and then it will be ready to go once that feature is available. So Hope this helps. Hope you enjoy using this data sheet, and hope it helps you look at your data in new ways and be able to think critically about its data quality. All right. Thank you. Take care.